All right, here we go. A practice problem, little Lagrange multipliers. Nothing big here. So the first step, we have to take our constraint and get it equal to 0. So I have to take this thing and I can move the x and the y to the right, or I can move the 40 to the left. I think it's easiest to move the 40 to the left with subtraction. And there we go. That's the part we're going to fill in. Now for the g of x. Now our function that we're trying to maximize is just x times y. So therefore, my new equation is going to have the variables of x and y and lambda. And my function just consists of taking my x and my y. I add lambda times x plus 2y minus 40. That's it. That's it. That's the whole Lagrange multiplier setup. Remember, it's your function, however many variables it has, f of x, plus lambda times g of x. And g of x is your constraint. F of x is the thing you're trying to optimize. So now what? Yeah, 15.3. This is back to the last section. This is just partial derivatives, set them equal to 0, and let's see what happens. So the partial with respect to x to the power 1, that whole thing becomes 0, so that leaves me with y. Plus, derivative with respect to x here becomes 1, so it's going to be 1 times lambda. The rest of these, there's no x's, so that all becomes 0. And again, if you have a hard time seeing that, just distribute this through and do it term by term. Okay, so partial with respect to x. Now let's do partial with respect to y. Partial with respect to y. That would be y to the first, so that's going to become 1, so I'm just left with x. Derivative of x is 0, derivative of 2y, so that just becomes 2. So this is going to be 2 lambda. And then the 40, there's no variables there, so that's just 0. And then last but not least, derivative with respect to lambda. There's no lambdas in the first term, 0. Lambda, that becomes 1, so it's going to be 1 times x plus 2y minus 40. And yes, every single time, it is just your constraint. It's never any harder than that. Okay, now what? Take each of these, set them equal to 0, and let's do some solving. My recommendation is always, just for sake of space and time and my brain, I'm just going to change these all to zeros. Whoops. Okay, now, always recommend find lambda in all of your equations and pick one of them to solve for. So I think it's easiest to solve for the one in the blue equation, the one from the derivative with respect to x, because then that would just be lambda equals negative y. So now everywhere I have a lambda, I can replace it with negative y. So I'm going to be left with 0 equals x minus 2. Oh, sorry, not minus, plus 2y. There we go. And that would immediately simplify down to be x minus 2y. So now I am kind of done with this equation, the derivative with respect to x. We're done here for a moment. We're going to move on. So now I have one equation with x and y. I have a second equation with respect to x and y. That should be an x right here. There we go. So now what am I going to do? Pick one of these equations, whichever one I like the best, solve it for one of the variables and sub it into the other one. Well, I think it's easiest to solve for this x here, because when I do that, I'm going to end up with x equals 2y. So it's a monomial, it's easy, I don't have to worry about distribution, and I'll just pop that in right here. So everywhere I have a x, I'm going to replace it with 2y. So that's going to leave me with 0 equals 2y plus 2y minus 40. Simplification, that will just come out to 4y minus 40. So now I add the 40 across, divide by 4. So that's going to give me y equals 10. And I am done. Once you get your first variable, now we just start working backwards. I say if I know y is 10, then I can use that to find x, because x is equal to 2 times 10, so therefore x equals 20. And if I know x is 20, well, hey, good news. Do I need to go back and figure out what lambda is? Whoops, I didn't want that pen. Let's try that again. Do I need to go back and figure out what lambda is? No, it was a variable I just made up. Now, what you will learn in another class is it actually does have meaning. It is related to the concept of marginals, but it's not part of our curriculum. It's not a question I'm ever going to ask you, but just know it has meaning. We're just not going to talk about it here. So I am ready to rock and roll. I know my x value is 20. I know my y value is 10. So what do? I take those, I put them back into the original equation and find out what my z value would be, find out my output. And so 20 times 10, that makes 200. So I know my output is, whoops, let's try that again. We want that up here, 200. So now I know I have a maximum. So you could write it this way and say this is a max, or you can say we have a max of 200 at 2010. Whatever kind of notation you want. Or you could say something like at, x equaling 20 and y equaling 10. If these had units, if it was a word problem, you'd say when we're making 20 cars and 10 trucks, we have a maximum profit of $200 million, whatever it would be. But the process is the process. And there you go. I hope that helps.